STW, Supervised Term Weighting System. That is a research happened in the area of NLP. Supervised term weighting, which means what? If I am asking a question, have you agreed that different terms in my question has different importance? Right? Some are question words, some are very focused words. So depends on the question, different terms require different weights. So that is being decided in this system of supervised term weighting. And in this case, I have decided the weights based on the objects in the image. From the image you can detect, there are many object detection systems. One example, can you say YOLO? Have you heard about YOLO? So YOLO is a perfect example for an object detector. So I can use any object detectors to detect objects present in the image. And I have compared that objects present in the image with the question words. And based on its similarity, what I have done is, I have trained or I have given different term weights to different question words. For what? To use in the next stage. What is our next stage? Next stage is the attention, where I am combining this visual and question features. And I have done a question guided visual attention, cross model attention, question text guided visual attention. So while guiding, I have given some importance to more attention. I already explained. Attention means where to look at the picture, selecting the correct bounding box. For that, I am giving an extra weights to keywords of the question. So that particular portion of the images will be more attended. And that is being done in multi-tier. So in the first tier, I have done an attention, normal attention based on a GRU embedded question vector and a normal image vector. Then in the next tier, that is next phase, I improve that visual attention with term weighted questions to give an extra attention. So that is in very simple words, that is what is happening in this multi-tier attention network, and this has been benchmarked on the publicly available data sets for the performance, and I got the reasonable performance in benchmarking, and this shows the difference or justification that the question word is not having same importance. The same word is not having same importance in different questions. That is what is illustrated in this picture, the justification. A particular term, say object, it is not having same importance in different category of questions. So that particular property of natural language is being explored by this product. Okay. And this is one work, and you can have this full work in, it is already published in the Elsevier journal, and this work is publicly available. So let's move on to another work. So that is about the first one. That in that I just benchmarked the general VQA system, and then I moved on to a domain specific VQA system. Here it is medical visual question answer. My domain, I selected the domain medical images. So especially radiographic images. Radiographic images has been experimented in this research work. So here my aim is to answer questions on, suppose you are uploading an X-ray and asking about that particular condition of X-ray, you need to get the correct answer. So that domain specific VQA has been developed. And in this also, in the image pipeline, I have used a different model which we haven't discussed. Here I have been implemented autoencoder, a denoising autoencoder. Have you heard about autoencoders? It is a deep learning model. Deep learning model specially suitable for feature extractions in a compressed form. When you look at the autoencoders, you can see something like it's a bigger dimension, smaller dimension, then bigger dimension. That is the structure. And this smallest bar we are taking as a feature. So denoising autoencoders have been used here because the images of medical images are not very much clear. So autoencoders are used as image, and of course question I have implemented BERT. And here also I had many challenges like the images are not very much clear. That was the first challenge. Then regarding the question, normal embeddings are not covering this medical terms. So there may be very much out of vocabulary issues due to the specific medical terms. And this was the architecture used. And here, after extraction of features, input features, for image I have used denoising autoencoders, and for text it is BERT. And then for fusion, here I am using the backbone of visual transformers. Visual transformers are being used for the fusion of these two models. In visual transformers, there are the main working principle is multi-head attention. Suppose we are having multiple heads, like Ravana, we are having multiple heads, and we are analyzing an image. What we can do? We can divide. You look at this part, you look at this part. We can divide, delegate the work to different heads, different brains. So that principle is being used in DIT. It is not acting as a single brain human. It is acting as a multi-headed human. So every head is looking at focusing on only one patch. Every head is parallelly working. So it will be very fast. Parallelly working. Otherwise, I have to start from this particular part and analyze every part of the image. Now, divided the work, given different heads, and they are looking parallel. So that particular multi-headed attention has been used here for speeding up the work and also for the context, for getting the meaningful embeddings. And this also benchmarked with the publicly available dataset, that is PQRAD. PQRAD is an available benchmarking dataset for this medical images. Similarly, other datasets are also available. And of course, we got the acceptable and efficient accuracy, and these are the some samples from that dataset. Images are like this and questions are like this. So this was the second work I wish to discuss. This is also published in Springer, Multi-Model Tools and Techniques. That indexed journal, it is having the complete details of this work. And now the third and final work I wish to discuss is about the very recent work. This is recently completed and waiting for publication. And this is an edge-based visual question answering which we have done. Edge-based in the sense, while discussing all the multi-model, for example, take the model ChatGPT. What about the parameter size of ChatGPT? It's billions and billions. We cannot operate it by our normal processing power. Or suppose, for example, we discussed one major application as helping visually impaired. The visually impaired person cannot carry a computer, supercomputer, and go for visual assistance, right? We need either as a mobile app or as a specs with intelligent smart glass, something like a smart glass or any wearable device we need. What about the processing power of a wearable device? It's when compared to GPU or a system, it is very less. Even in the mobile, it is very less. But what about the weights or what about the size of such models? We discussed many models like Clip, Blip, ChatGPT, etc. All these models are very resource consuming models. We cannot directly implement, even though we have better solutions there, we cannot directly implement that on any of the wearable system. So there comes another gap or another thing where we need to research: edge deployable multi-modal systems. Edge deployable multi-modal systems. And that is we have experimented the same on edge device. This is for visually impaired users and VQA system, and also for this also there is a publicly available data set is there. This data set is available, which consists of images taken by really visually impaired users and some audio questions. So first we need to convert this audio to text, then we need to process image and text. Many challenges are there with the data set. Can you think about an image taken by visually impaired? It is out of frame, out of focus, blur. So many images are like that. We cannot answer some questions in that. So identifying unanswerable questions is also one challenge here. Okay, so that is done here, and another thing we have done, and for this we have used a polygamma refined, changed, modified polygamma model, which is an available multi-model AI system in the group of Clip, Blip, GPT, etc. You can include this also, polygamma, but that is many resource constraints. Like we cannot implement that for a visually impaired users' glasses. So we have done an edge deployment, which is done by optimizing that model using NVIDIA Jetson Nano. Have you heard about Arduino board? Raspberry Pi? So these are the small scale edge devices. For such a multi-modal task, they are not applicable. So its higher version is NVIDIA. Every year they are releasing new and new models. But the price is it's there. You need some kind of funding to do this research. This has been done as part of a research seed money funding of KTU. We have done this on an edge device, that is Jetson Nano, NVIDIA Jetson Nano. We quantized this large model so that you can implement that on a wearable device. That was a recent research and which is under publication, so architectures and details are not included here. So these are some works. So similarly, there are many multi-modal applications. One where I am expert, that is what I explained, visual question answer. You can have image captioning, you can have image generation, text-based image generations, domain-specific question answering systems. Question answering is still active. It is still active. But you need to think where to improve, which domain you need to select. Select a rare domain where the work has not been done. So you can select in that way. And now some possible future trends I have listed here. First one is, this is the ultimate novelty. You can think about a unified model where now we are developing like a ChatGPT. How to improve that unified model for different tasks. One model for image captioning, one model we are using another one for visual question answering, another one for video summarization. Right. So we need in a futuristic AI, we need a generalized multi-model AI system. That is one approach. What is happening as part of ChatGPT? What they are doing is this research. ChatGPT 3, now 4, now coming 5, right? So such a result which requires multitask optimization and the catastrophic forgetting when you are giving new task. Catastrophic forgetting is the system the weights will get overwritten so that it will forget the previous task. Main task it will forget. That particular tendency in multimodal AI systems are known as catastrophic forgetting. So we need to do some research to avoid that catastrophic forgetting. If I am basically built for visual question answering and then I have trained for image captioning, I should remember both this, not overwrite. Okay, that is continual learning. Next is you can try for more modalities. Now most of the systems focus only on vision language. Most of the celebrated systems are coming under vision language models. Only 2 modalities. Of course, autonomous driving cars are there, which combines more modalities. Except that, works are very less. We can think about what are modalities like sensor data, EEG means signals, signal processing. What are the signals? We are also planning a new work based on this multi-modal signal processing. So what are modalities we can add to this system? That is another research direction you can think about. And then this I have already discussed. Edge-based systems. Any multi-modal system, if you are developing, if you wish to go viral, it should be used by all laymen, right? For use by every layman, it should be either as compatible to a mobile. So what we can do for edge deployment? Now we have millions of parameters to. This is a research domain. Lightweight multi-modal systems. That is another research domain. You can think about lightweight multi-modal systems. And this is very hot topic. Very hot topic. Trustworthy and responsible multi-modal AI. Now everybody is thinking about the security. We are simply uploading our images and all data to ChatGPT and asking to modify it and give answers, etc. But the major concern about privacy, data privacy, and this term is very important. Hallucination detection. Hot research area today. Hallucination detection. Which means what? Every AI system's ChatGPT, it will give answer even if it don't know about that. Right? That is hallucination. It is dangerous in some cases. If a kid is playing with ChatGPT, it's fine. If it is anything related to medical or any legal or very crucial situations, giving such hallucinated answers even though the system doesn't understand the context, it is giving some answers. Even if you are asking about a cat, it will answer. If you upload image of a dog and ask about what is the color of cat, it will respond as the cat is white color. Right, so that is hallucination. Hallucination detection and avoiding hallucination is very relevant topic right now. So that is required for all domains of multimodal system. This also you can try so that you can build a trustworthy and responsible AI system. Then another, this I think already discussed, agentic AI. Yesterday's topic about agentic AI. So agentic AI is another thing. What is the difference between traditional AI, multimodal AI and agentic AI? What is the basic difference? What do you learn? Key takeaways. Agentic AI. How you can differentiate a system as multimodal AI and an agentic multimodal AI? But traditional system requires human intervention. We need to trigger it with a prompt. or user twisting. The other thing, agentic AI is it will plan, it will have sets from the context, from the environment, it will identify some goals, set some goals, plan and implement the act. It's something like an automated system. So that is also area. So you can take as adding more modalities and having some domain specific systems that can be one area, or you can try for lightweight systems. What are the different possibilities to have an edge deployable systems? Then of course hallucination detection. Among this I prefer lightweight and hallucination. So I think I am able to give you these things from this lecture. I introduced what is multiple modalities, and I think you agree with me that adding more modalities will improve the result. Is it? Have you all agree about that? If you add multi-model learning will definitely improve the understanding of your AI systems. And also in that, how you represent your inputs and how you fuse them is very crucial. How you represent, you need to take voice decision regarding how you are going to represent each of your modality. If you are taking biological signal, how you embed that should be decided wisely. Then, of course, BQA. I hope you got about the flow of one particular multi-model application, that is visual question answering, and of course, future. Some sparks on future research directions. So that's all. Now we can have some queries or discussions. Hybrid fusion. First you can fuse two embeddings of text, which I have done, I have already shown. Same modality, that's what you mean, right? For the text itself, we can try for multiple embeddings and then fuse it, or you can try any hybrid fusion. Finally, you need to fuse this text features with image or audio, anything depends on your work. So where to fuse these two different things? One you can use as an early fusion, and one you can keep for a late, intermediate fusion. Late fusion, I think will not work for general applications. Early and hybrid fusion you can try in that case. If you are using multiple embeddings for different same modalities, you can try for any hybrid fusion techniques.
Thank you, Sudhir. It was a wonderful session, in fact. So, partially I could hear it because of some arrangement, but I think definitely your session would have opened some, way of thinking to the future researchers. In fact, those are not thought about this particular area or domain. So definitely it's an eye-opening session, I would say. I request one of the participants also to give a honest feedback about Nan's session, so it will be like the resource persons also, they will be like very happy to hear it from you. So it was thank you, ma'am, for accepting our invitation. And it's a special moment for us. Thank you very much for planning a valuable time. So I request one of our participants to give a honest feedback about Nan's session. Please come forward.
so very similar. Your presentation had more questions for a research to read. So the thinking is better, I think. That's so very good.
So, thank you very much for the audience feedback as well. So, we will have the session, next session at 2 o'clock. So, 1 to 2 we have the lunch break. So, we have Dr.